What are stress trajectories in stress analysis? Imagine tracing the flow of stress inside a metal beam or a complex structure. You might wonder how engineers visualize the way forces move through materials. Well, stress trajectories are the lines that show this path. They are curves inside a material that representing the directions of principal stresses at every point. Principal stresses are the normal stresses acting on specific planes where shear stress is zero. These lines are drawn so that their tangent at each point aligns with the direction of one of these principal stresses, usually the maximum or minimum. Think of them as the stress highway routes inside the material, guiding us through how forces transfer and distribute. In stress analysis, these trajectories help us see the stress patterns more clearly than just looking at numbers or simple contour plots. Because stress is a tensor quantity, it has both magnitude and direction in multiple planes, making it tricky to visualize. Stress trajectories simplify this by showing continuous lines that follow the principal stress directions. This makes it easier to interpret complex stress fields and understand how forces flow through the structure. For mechanical engineers working on design and analysis, stress trajectories are very useful. They reveal the first paths inside a structure, helping identify areas with high stress concentrations or potential failure points. For example, in reinforced concrete design, stress trajectories guide where to place reinforcement bars. They show the best directions for placing steel to carry loads efficiently. In plate bending or membrane problems, these lines help determine the best orientation for stiffening elements or reinforcement. Mathematically, stress trajectories are defined by differential equations based on the stress components at each point. In two-dimensional plane stress problems, the angle of the principal stress direction is calculated from normal and shear stress components. These angles are then used to draw the lines by integrating the differential equations. Today, modern finite element software can visualize stress trajectories directly on models. These tools display lines or curves that follow the principal stress directions and can be colored or thickened to show stress magnitude. This visual aid helps engineers quickly see where the highest stresses are and how they flow through the structure. In summary, stress trajectories are continuous lines that map out the paths of principal stresses inside a material or structure. They are an essential part of stress analysis, helping engineers perform detailed stress calculations and optimize designs for strength and durability.